Assalamu alaikum students. Today we have to study or we are going to study correlation analysis. Correlation analysis is the degree of association. It tells the degree of association between the two or more variables. If two or more quantities vary so that movements in one tends to be accompanied by the movements in the other, then they are said to be correlated. Correlation analysis does not answer the questions like why there is cause and effect between two variables. For example, the correlation between the sales and advertisement cost is high, but correlation does not explain why. The following examples give you the details of the relationship between the variables or different examples. Example number one, relationship between income and years of experience. Students, we know the work experience increases, the income also increases. Second example, the relationship between amount of rainfall and yield of rice are also connected. Relationship between price and demand of a commodity. Relationship between nature of work and motivation to work. Relationship between height and weight. As the height increases, the weight also increases. So there may be a relationship or might be a relationship between weight and height and other examples that we have studied. Correlation coefficient. Correlation coefficient of correlation is a numerical measure of the degree of association between two or more variables. It is concerned with findings. Number one, whether or not the relationship exists. The value of correlation coefficient ranges from -1 to +1. Zero correlation coefficient characterized that there is no linear relationship between the variables. Point number two, where the correlation concern is direction of relationship within the variables. What means the direction of relationship between the variables? Positive correlation coefficient shows the direct and the negative correlation coefficient shows indirect linear relationship between the variables. Correlation coefficient is positive when an increase in one variable is associated with an increase in the other variable and a decrease in one variable associated with the decrease in the other variable. The following example shows if one variable, the direction of one, if one variable is increases, the other variable also increases. Both the direction of the increase, both the arrows shows the same direction. And in figure B, here is also the direction of the relationships remains the same between the two variables. So the point was explained before here. Correlation, I'm reading again. Correlation coefficient is positive when an increase in one variable is associated with an increase in the other variable and a decrease in one variable associated with the decrease in the other variables. So the direction of the both the variables are same. For this reason, the correlation coefficient between the variables remains positive. Some examples of the positive relationship are: number one, daily temperatures and electricity demand. Explanation: we observe as air temperature increases, the demand of electricity increases during summers. As the air temperature decreases, the demand of electricity also decreases during winter. In both cases, the direction of relationship is positive. Example number two, Amount of rainfall and water in river channels. Explanation. During the rainy seasons, we observe the flow in water channels also increases. It also happened during summers when ice melts makes the floods in water channels. In both cases, the direction of relationship is positive. Correlation coefficient is negative when an increase in one variable is associated with the decrease in the other variable. The following figure shows the direction of the variables from the arrows. We can see the opposite direction between the variables. The inverse relationship, the examples of inverse relationships are as number one, product price and sales volume. Explanation. The increasing price of product decreasing the amount of sales. In this way, both variable price and sales are negatively related to each other. Example number two, speed and time to cover a distance. Explanation. We observe as the speed of vehicle increases, soon we arrive at the destination. The direction of association between speed and time taken to complete a destination is inverse. Point number three, the magnitude of relationship such as strong, weak, or negligible. The following figure illustrates the ranges of correlation coefficient that characterized the strength of the relationship between the variables. Students, we can see from this figure if the correlation coefficient is 0, this means there is no relation. And if the correlation coefficient between the two variables ranges from 0 to 0.25, there is weak relationship. If 0.25 and 0.75 correlation, the ranges of the correlation characterize the intermediate or moderate range. 0.75 to 1 characterize the strong relationship between the variables. And one, if the correlation coefficients is 1, this means there is a perfect correlation. The ranges of the correlation is same between the right side and the left side, but there is a difference in sign. The sign difference shows the direction of the association between the variables. The right side relationship with positive numbers characterize the direct relationship between the variables. On the other hand, indirect relationship. The figures values or ranges also describe here. We denote the correlation coefficient with R. R is equals to 0. This means no association or correlation between the two variables or more. If R between 0 to 0.25, there is weak relationship. 0.25 to 0.75 explains or characterize the moderate correlation between the variables. 0.75 to 1 is strong correlation between the variables, and if R is equals to 1, characterize the perfect correlation between the variables. Graphically, students, the following figures I have taken from Applied Business Statistics, third edition by Trevor Wagner from page number 301. A scatter diagram or plot graphically displays both the nature and strength of the relationship, the independent variable between the independent variable and dependent variable y. A visual inspection of the scatter plot will show whether the pattern is linear or not, whether it is direct or inverse, and one can guess the strength of association between the variables. The above figure, the above figure shows the perfect positive linear correlation. This figure explains how the ideal situation to hold perfect direct linear relationship between the variables. One can compare the figures with this figure to identify how differs the figures from the above figure. The above figure shows the strong direct positive linear relationship with small dispersion. See students, if we compare the figure earlier that we have studied and this one, there is a small dispersion. But see here, what is the discipline between the points of x and y? It holds the perfect or ideal situation. Now, the figure below is differ from this ideal situation. This means the figure is not perfectly correlated, but it is a strong or direct positive relationship with a small dispersion. For above figure, the value of correlation coefficient remains in the range from 0.75 to 1, but not perfectly 1. In the following figure, the dispersion increases between the variables. The above figure shows the moderate direct or positive linear relationship with greater dispersion. The value of correlation coefficient for this figure remains between the ranges from 0.25 to 0.75. The above graphs, all graphs, are related to the direct linear relationship. Now, what graphical representation related to the negative relationship? We have this graph. The above figure shows perfect inverse or negative linear association where R is perfectly -1. Perfect negative linear association. This figure explains how the ideal situation to hold perfect inverse linear relationship between the variables. One can compare the figures with this figure to identify how differs the figures from the ideal figure. Now, from the second figure, the dispersion increases. The difference, one can easily see the difference between two graphs. There are more or many dispersions between the points or more dispersion between the points. But see the ideal situation. The figure 2 differs from this figure. For this reason, above figure shows the strong inverse linear relationship with a small dispersion. For this figure, value of correlation coefficient remains range from 0.75 to -1. This figure, there is a more dispersion between the points than the figure 2. This characterized the moderate inverse linear relationship with greater dispersion. For this figure, the value of correlation coefficient remains in the range 0.75, 0.25 to negative or negative 0.25 to negative 0.75. Now, compare this figure from the previous figures. This figure characterizes no linear relationship between x and y variables. Values of x and y randomly scattered for any given x value, y can have any value over the wide range. Here, the value of the correlation is 0. because there is no linear relationship either from the positive side or from the negative side. The points are widely scattered. There is no a discipline linear trend from the previous graphs. For this reason, there is no linear relationship or R is equals to 0 in this figure. Mathematically, the simple correlation coefficients between the two data sets is represented by the following Pearson correlation formula. The correlation is denoted by R as we have studied earlier, and the formula which is expressed is in this mathematical form is belongs to the correlation coefficient. The correlation coefficient denoted by R, the R is sample correlation coefficient, X is the values of the independent variable, Y the values of the dependent variable, and N the number of paired data points in the same sample. Students, note that the correlation coefficient between X and Y remains same between Y and X. Now students, we have another concepts related to the correlation coefficient which we call coefficient of determination. The coefficient of determination measures the percentage of variation in the dependent variable y that is explained by the independent variables. The coefficient of variation usually denoted by r capital R square or simply by small letter r square. It can also be called r square variance. The coefficient of determination ranges between 0 to 1 or in percentage 0% to 100%. The formula for finding the correlation, the finding formula for the coefficient of determination is r square multiplied by 100%. The following figure shows how the relationship explained by the numbers. From 0% to 50%, there is weak linear relationship between the variables. Or the variance, the explained variance between x and y is weak, or the independent variable explains weakly association with y, or 50%, the 50% value is characterized as the x variable moderately explain the y variable. From 50 to 100%, there is a strongly x variable connected to y variable. The perfect 100% value of coefficient determination characterize the x variable 100% describing the y values. Interpretation of the coefficient of determination or R square. Students, it's enough for this time, and we will explain from the next example of the correlation coefficient between the variables. Till then, Assalamu alaikum.